Hello, today I will present our project of predict machine failures by using various machine learning methods. First, introduction in the new industrial field, predicting and preventing machine failures is crucial for efficiency and reliability. Advanced predict maintenance strategies are essential for industrial operations. So this project is aimed to analyze milling machines' failure data for predictive maintenance. We want to use these data features to predict this machine will fail or not. So first, we use supervised machine learning models like decision tree, k-nearest neighbors, and some other machine learning models to predict failures. We also explore a contextual learning model without relying on the failure labels. So first, data description. This data comes from Cargo and is a synthetic data set that reflects the real predict maintenance in content in the milling machine industrial. The data has the ID is from 1 to 10,000, and the product ID means that it has machine type LMH and the machine generated product. The next is the important features like air temperatures, process temperatures, rotation speed, and torque and toe wear. Also, a target indicates machine failure or not. Failure type will tell us what's the type of failure. So in this project, we only use the target as our purpose of the machine learning. We will use the features to predict this failure is 0 or this failure is 1. So next data visualization, we see how many machines in each type. And we can see the M has 30% of the type machine and H is 10%. The most one is L has 60%. Also, we see how many data is failure in all the data sets. We see it's 0.4% data show failures. These features show the failures in the data set. Next, data visualizing about correlation between these main features. So there correlation between air temperature, process temperature, rotation speed, torque, and the toe wear. This color of this dot shows blue is the type M, orange is type L, green is type H. We can see most data are scattered, only has the temperature. The two temperature data has a correlation. A rotation speed and torque has a correlation. This is reasonable because they are same thing. Also, this in the diagonal line, this curve shows that the data range of each type. We can see as machine H, this air range, the process data range has a small range. The most range shows in the L. This data features range a lot in our data set. So from that, we can see that most type are scattered distributed in the other features. Next, we want to see is data suitable for set boundary or not. So we can see that in this figure, the blue dot shows the target is 0 means that the machine is not a failure, and the red shows 1 is machine failure. So we can see the distinct boundary between the normal and failure data. So this suggests that the data set is suitable for separation, indicating its potential use for machine learning. Also for the outer layer, this test for the outer layer for each features by the different type of the machine. Because in this in the purpose of the project, we want to find the failures. But when the machine failures, the features always fail to some outer layer range. So we can find here, we can see some features outer layer maybe shows this machine in the failure state. So this gives us a view of that the most during the rotation speed and the torque has most of the outer layers. It may be because the machine has failures. So next we conduct the data processing because the data, there's no missing data in the data set, and the most data in these features has a large range. So we conduct a normalization. After normalization, we want to see that it's need PC or not. We use sklearn to observe the first 5 components of the principal components. They are around 90%, but despite the there is not big features in this data set, so we want to keep all the features during our training. So we decide to not use the PCA. We just use the normalized of each feature to input our machine learning models. Next, we conduct the machine learning model. First, we use the decision tree and set the hyperparameters of the different max steps. And finally, we find the max steps is best is 24 and get the 0.8% of the mean balance accuracy. And the KNN, we set all labels, and only in the label 4 they got the best accuracy, but it's only 0.6. And we also try to the Bayes model. We only want to see the result, so we just set 20 cross validation, and this result is only 0.67. Also, we try the random forest tree with gradient boosting. And in that case, we only use the default values, and because it's a strong method in this introduction, so this shows mean balance accuracy is 0.82. Also, these two similar machine learning model is SVM and is FCVM. We try different hyperparameters C and gamma because Gaussian kernel is very useful in this model. So we only set model is RBF. So after that, we find the best parameter C is 100, gamma is 0.1. Also, we try the neural network model set 2 layers because in this case, I think 2 layers is very enough for this training. And the set first layer is 50, next layer 20. And in this case, after cross validation, it show mean accuracy is 0.83 and SVM is 0.78. So after that, we can see from now the best model is a neural network and followed by the random forest tree gradient boosting. So we conduct ANOVA F5 analysis. This shows that the performance of the model are not equal. So we conduct a pairwise comparison between these models. After the whole process, we found that in the supervised learning model, the best model is neural network. And this result, balance accuracy is 0.83. And the similar model is not gradient boosting, is the decision tree. So there too is a similar model. After that, we want to try the unsupervised learning. We don't use the labeled target. Which means we don't know the trained data the machine is failure or not. So we use the idea of the contrastive learning. So in each batch of the training set, we select each vector. We select each vector as our current vector, and we will formulate the positive pair and the negative pair. So because it's only 3.4% of the data is failure data, we suppose that if we choose a random vector from other data, it's normal data. It will formulate a positive pair with the current vector. Also from negative pair, because we don't know which vector is a failure, so it's very hard to choose negative pair. So we only calculate the distance matrix of the current batch and choose the longest distance from the current vector and to find the negative vector and formulate the negative pair. So now we have a positive pair and a negative pair to input in the bilinear model. This bilinear model will have the 2 vectors and to output the 1 features. This 1 features is 1 value. Because the positive pair, we set their values as 0, and negative pair, we set their value is 1. its failure is also is a binary number. So we can use binary cross entropy loss to train the model, and we input this batch again and to this batch. After that, but the result didn't show the good result because I think when I design this negative pair, it has a problem because most vector, when they find the index of the negative pair, they choose the same import pair, it will have the problem when I'm training. So during training, you can see that the loss are not decrease when they at a certain range. So it's only 0.61% balance accuracy during that. Despite that, this has very low balance accuracy. It suggests that this may be a hopeful way to we can contact in the future study because it shows that we didn't use the label data and we can predict the failures. Also, its result is close to the k-nearest neighbors. It's supervised learning. So the conclusion is report is that supervised learning models can be used to predict machine failures, and we can have a good result in decision tree, gradient boosting, and neural network. In this case, neural network is the best models to predict the failures in this data set. After pairwise comparison, we can see that the decision tree is the most close performance with the neural network. Also, we try the unsupervised learning in the constructional learning model. It shows potentially capability for the future research. It uses unlabeled data to predict failure of the machine. So that's all of the project. Thank you. Next is the reference. Thank you.